Good morning. Good morning, everyone. Hi, welcome to the parallel session on computer vision. Today we have a lineup of 3 great speakers, and then we will have a discussion panel. So it's going to be 3 talks of 15 minutes, and then a discussion panel where you can ask questions to the speakers. So today we have the honor of having 3 Latin American faculty giving talks on their research. So I think this is a great opportunity. And I'll go ahead and present our first speaker. Is Jorge Sánchez. He's the head of Applied Machine Learning Research in Mercado Libre in Argentina. Jorge is also a member of the CONICET, the National Council of Scientific and Technological Research in Argentina. Jorge received his PhD in Engineering Science from the Universidad de Córdoba. And Jorge is also the recipient of the prestigious Condorcet Prize in Computer Vision for fundamental contributions to the area. And also you might know Jorge from his talk on Monday on computer vision architectures. Fundamentals, sorry. So with that, let's give a round of applause to our first speaker.
Thank you. Thank you. Okay, we are a small room. I think you all hear me okay, no? My talk will be it's entitled Comprehension and Dialogue, a case for the study of the edge cases in vision and language research. This is based on some joint work with Mauricio Mazzuecos, Hernán Maina, Tomás Badora, Franco Luque, and Luciana Benotti, which is in the parallel session on NLP. And they are from the Universidad Nacional de Córdoba and from the Dialogue and Vision group. And the talk will be about, or I will talk about, 2 problems, which I believe show us some examples and test cases that show some of the limitations in the way we approach some vision and language problems today. The first of these problems is referring expression comprehension, which is the task of we are given an image and an expression in natural language, and the goal of the model is to provide the localization of the object or image region that is referred by this natural language expression. What we observe in this problem is that there are some issues. The first one is that it is usually thought as if we were dealing with a object detection problem. And in fact, we are dealing with a much richer and complex grounded language phenomena. Usually, if you go into the literature of REC, you'll see that evaluation metrics, the evaluation metrics people use is intersection over union with the target object. And this hides many rich and interesting phenomena that we observe with language, with the use of language. Also, there is this tendency, which is not exclusive to this field, but also to the machine learning and computer vision in general, which is using average performance metrics. And in this particular case, this hides many interesting phenomena that arises from using language as interface, and hinder us for a better understanding of some of the problems that arise in this type of task. So our initial hypothesis is that there are different type of expressions that demand for different skills for the models. In our work, what we did is we did propose a way to classify different expression types, at least a first classification level, and we consider these four classes. Expressions that use spatial prepositions like absolute and relative. I will talk more about this in a minute. Then those expressions that use ordinal expressions. There are other expressions that require you to use a landmark object, that you refer to an object in reference to another entity in the image. And there are other expressions which we term intrinsic ones, when they are the easiest one, and perhaps there are these intrinsic expressions, type of expressions are the more closely related to zero-shot detection or detection problems in general in computer vision. And as we see, there is in the case of spatial and intrinsic relations, they predominate. If you look at some statistics in some of the data set used for the problem. And one thing we should note here is that these categories are not exclusive. You might have different. You might have an expression assigned to more than one category, because, for instance, you can use spatial prepositions in relational expressions to identify the identity of an object. If you say the chair to the left of the person, for instance. So there is different statistics, and what we wanted to test next is if there is how it's the behavior of a reasonable model, a reasonable referring expression model. So we designed a robust baseline. I mean robust because it gives us performance which is comparable to the state of the art and in a more simple way. And we found indeed that the performance for the different expression types is indeed different. We see that the intrinsic type is the most easy one, while the more challenging ones are ordinal and relational expressions. We found that, well, the complexity of the task correlates with the length of the expression. If shorter expressions mean that you don't need to resolve any ambiguity on the image. For instance, in this case, you can just say the dog, and since it's the only dog in the image, you can uniquely identify this object instance. And in this sense, we can think that intrinsic and absolute spatial orientation are trying to solve a matching problem. You try to match a keyword, the object category, with a region on the image, or you can try to match a spatial word like left, right to an absolute location within the image. We saw that the models are able to learn that. While for other type of expression, like relational or ordinal, you're trying to solve at least a basic level, some visual reasoning task, because you need to identify different objects and their relations between them. So based on this, I won't go much into details because I don't want to concentrate on results, but to show more the problems we still have with these models. We show in this work that by adding some additional spatial constraints like biases, like inductive biases, we are able to improve on these categories, but still there's much work to do here. But what I found more interesting is that using these models, we were able to do an error analysis on a subset of the test image of some of the data set we used. And we found another set of skills that goes beyond the ones that we proposed originally, that were spatial, ordinal, and relational. And these skills are something that we would like our models to have, but still are lacking these abilities, like being able to refer to parts of objects. When you say water's near man's back, you need to resolve the back of the man. Or there are other examples when you refer to the head of a guy, when you need to know what the head is a part of a larger entity. Or sometimes you have to change the viewpoint. You usually assume that the reference viewpoint is the viewpoint of the people that took the picture. And sometimes you say you have to assume an orientation of some object, for instance, directly above and behind the little boy on the bike. What is behind of the boy? It's not behind the boy towards the water, but behind the boy in the direction of the motion. So it's really tricky. There are also appearances of fuzzy objects, which you won't solve by running object detectors, which is very challenging. And these fuzzy objects are non-physical objects that appear because of contrast relations, border edges, and implied structures in the image, which are not physically an entity. There are also interesting cases when there are typos, but typos is part of human language, of written language, so we should take care of them, not trying to correct them, because we use abbreviations all the time. This example is interesting because the typo here is replacing sky by ski. And both models, oh, by the way, sorry, in blue here is the ground truth, the orange one is our baseline, and the green one was this extended model that we proposed. And we see here that both models predicts a bounding box that is on the bottom of the image, and there where skies are supposed to be. Skis are supposed to be instead of sky. So it's an interesting case. Well, this is one problem. The other problem is visual dialogue, and in particular, a particular instantiation of the visual dialogue problem, which is when the participant of the dialogue want to solve some task. In this example, this is an example from the Guess What dataset. In this problem, you have two persons that interact, a questioner and an oracle. The questioner can ask question in natural language, and the oracle has to. The only things he or she can do is to answer yes/no answers. And the goal of the task is to identify the identity of an object which is only known to the oracle. The oracle is given, for instance, this green car, and the questioner task is to identify these cards by asking questions, and the oracle can say yes, no, and as this example. There is a rich literature and linguistic, especially, that shows that, or that propose that the dialogue history is important to solve this type of task, but it's not clear how to incorporate the dialogue history into these kinds of problems, in vision and language problems. So we proposed an approach which we term region under discussion, which is inspired by the linguistic concept of question under discussion. And what the root is a way to encode the constraints implied by the dialogue, by the evolving dialogue terms. So in this example, I think it will be clear. The questioner asks if there's a person without any other constraint. All possible objects within the image are candidate objects for the target one, and the oracle says no. So we can discard the person class. Then the questioner do the same with the sky. The oracle says no. The questioner asks, "Is this a car?" It's a confirmation question. The oracle says yes, and then finally it disambiguates which of the car corresponds to the target by asking some spatial related question, and the oracle says yes. But it's interesting to note here that you can only answer this question correctly if you know the history. If I present you only this question without any of these previous ones, you won't be able. It could be any object in the image, on the left side of the image. And it's interesting also that this spatial expression on the left is on the left of the root, of the region which is considered, or which has been agreed is the region, the interesting region in the image. So, using this, we did two things. First, we annotated a subset of the Guess What dataset by marking those questions that change the polarity of the answer according to whether you know the dialogue history or you don't. So we did an interface where we showed the image, the target, and a question. And if I show you it is the leftmost, you don't know really the leftmost of which entity. So we got some annotations there. We also proposed a simple way, because the Guess What dataset is based on MS-COCO. We have segmentations, objects, categories, etc. So we proposed a simple way to annotate with root the dialogue samples in the dataset. And so we proposed two simple extensions to some models that were used in the literature. by including this information, the relative location of the target within the root in both cases. So we wanted to see if how performance changed. And we indeed observed that taking into account the dialogue history with this concept of root indeed helps improve on questions that are history dependent. So there is no relative improvement on all categories, but if you look at the subset of the test set that include this specific question that change the polarity of the answer, we see a marked improvement in both cases. This is the baseline and by incorporating the root. So to conclude, I think there are many unsolved problems that are in vision and language that are not, that won't be solved, I hope, I think, yet by scaling up models and data. And these are not things that we should discard. They are not outliers. They arise by the way which we use language. So are integral part of the problem. And these edge cases, what they have is that they teach us a lot about the limitation of our model, so we can learn a lot. We have also learned that vision and language is or should be a multidisciplinary field that requires a really multidisciplinary mindset. Having language capabilities injected in in vision models or vice versa is just the tip of the iceberg. We can train vision and language like for captioning, for vision and language alignment, but this is really the start of the problem. It's the beginning. And we don't want to forget the language is is for humans to communicate. So either if it's human to human or human to a machine, there is always a human in the loop. And there are a lot of things that come with that, especially for someone like me, like comes from a computer vision background, and language is open as a really whole field of problems. But okay, that's it. Okay.
Thank you very much, Jorge. So I think we have time for a couple of questions.
Sure.
So in the beginning, you showed these 4 different categories of detection.
Yes.
And so I was wondering whether you use that mostly to evaluate how some methods perform, or are you able to feed that into the models to do some conditional learning, because some cases might...
We didn't want to explore that possibility first, because when we started working with this, we did some error analysis. We looked at some samples, and we saw that there were many cases that were contemplated by these categories, but it's a possibility. Yes, I believe that. I think we should go beyond the traditional architectures now. There are some approaches like module networks or other that share attention between different objects and take to capture relation. I think we should go in that direction, but yeah, it's a possible way to go.
I have a question. The last model, the last problem that you mentioned,
Yes.
depends highly on the detection of the
Yes.
model. How do you handle
Yes,
that?
that's
If there is a miss on
that's true.
on the card, for example, how do you handle it?
To generate the root, this is a laboratory question. It's a laboratory problem, sorry. It's very constrained because we assume, we took the detections from the annotation of MS Coco. So we are interested in the interplay in the dialogue. We didn't want to inject, to plug another uncertainty source of error like an object detector or something like this, because it was the interest of the work. But indeed, detection errors can be tricky to handle, yes.
Thank you. I think we can leave, if there are more questions, we can leave them for the end. Remember, there's a panel discussion at the end. So let's thank Jorge once again.
Okay, thank you.